Good morning, pre-calc. So we're going to move on Monday and Tuesday. You should have done two variable systems of equations. Now we're going to check out, once again, two variable systems, but we're going to check out some situations where maybe one or more of our equations is not linear, which is, an equation that gives us a line when we graph it. Okay, so just like in our previous lesson, we could have one solution, we could have no real solution, or infinitely many solutions. But because we have some nonlinear expressions, we could also just have multiple solutions, like 2, 3, something like that. So we are actually going to skip this whole graphing part, remember, due to the fact that not all you guys have this printout, and it's very annoying to have to graph that. And we're going to go right to solving them algebraically. So we essentially have the same options of substitution and elimination. So now we just have some more complex equations that we're going to be dealing with. So to start off, let's go ahead and check out number 5. In this equation, in this system, you'll notice that we have y equals for both these guys. When you do see that, right, you are in a very good situation, because all you have to do is just set these two things equal to each other, because they are both equivalent to y. So essentially what we can do here is x squared plus x minus 2 equals 1 minus x. And then I can go ahead and solve by getting everything equal to 0, because this is a quadratic, right? So those guys are going to cancel. I'll get 0 on the right hand side. I'm going to have x squared plus 2x minus 3. And then I'm going to go ahead and factor this guy. And I'm going to have x and x, two things that multiply to negative 3 and combine to positive 2, or positive 3 and negative 1, right? And then I'm going to go ahead and solve for both these guys. Okay, so I think we're going to have two answers here. One of them is going to be x equals negative 3 and x equals positive 1. I just set each of them equal to 0 and solve. And those ones are pretty easy to do in your head. But remember, our solutions here are going to be coordinate points. So we actually have to take this negative 3 and this 1, and we have to plug them into either of our equations to figure out what the y is that corresponds with each of them. So, for example, I'm going to go ahead and I'm going to take this negative 3, plug it in. I'm going to do this nice easy equation here. You should get the same answer no matter which one you use, though. I'm going to do 1 minus negative 3. So y equals 4 for that. So that ordered pair is negative 3 comma 4. So there's one answer. And this other guy right here, I'm going to do the same thing for. I'm going to do y equals 1 minus 1, and that's 0. So we're going to have 1 comma 0. So the two places where these graphs would meet or intersect are at negative 3 comma 4 and 1 comma 0. Right? If we were to graph these guys, this guy would give us a parabola, right? A quadratic, something like this, right? And then this would just give us a line. So that line must hit two parts of the parabola. Right? So number 6 would be pretty similar, so we're going to skip that one. You're just going to set them equal to each other, and then you would go ahead and you would set it equal to 0 and factor. And now let's look at a situation where we're going to have to go ahead and use some elimination. So in number 7, we have x squared plus y squared equals 52. So that's actually the graph of a circle. Okay? And then here we have 3x plus 2y equals 0. So in a situation like this, we're going to have to first go ahead and figure out which type of elimination we're going to use, or which type of method we're going to use, substitution or elimination. I think I previously said elimination, but if you think about it, we'd have to multiply one of these guys by either y or x, and it would give us a weird variable. Like if we multiply by x, we'd get 2xy, and that wouldn't be very helpful. And if we multiply y, we get 3xy over there. So instead, let's actually go ahead and try doing some substitution. This guy looks like it's a lot easier to solve for one of our variables. So I'm going to go ahead and solve for x here. So I have 3x plus 2y equals 0. I'm going to subtract 2y and divide by 3. So it looks like x equals negative 2/3 y. And then with substitution, remember, I can just take this guy, put it in a box, and I can go back to my x value right there and plug that in. So I'm going to do negative 2/3 y squared plus y squared equals 52. Right? And then let's see what we get here. So when I square negative 2/3 y, I got to square both these guys. That's going to be 4/9. It's going to make it positive, right? Because the negative will cancel. Plus y squared equals 52. And then these guys are like terms. One of them's a fraction, unfortunately, but if we just think of this guy as having a 9/9 in front of it, which is just 1, right? It's pretty easy to add them up and get 13/9. And then I just have to do two things. First, I'm going to multiply by 9/13, the reciprocal, to get rid of that guy. And that should give us something like, I believe, 36. And then we take the square root, and we're actually going to get two answers. We're going to get positive 6 and negative 6. So we have two different y values. And then to figure out what x values go with each of them, I'm just going to go back to that box, just like we did with substitution the other day. So I'm going to go ahead and for positive 6, right? Oh, sorry. For positive 6, I'm going to go ahead and plug that in and do x equals negative 2/3 times 6. And that should give us something like negative 4, I believe. So one of my answers is going to be 6 comma, did the wrong order. Negative 4 comma 6, right? And then I can plug in negative 6 in there as well. So that's going to be x equals negative 2/3 times negative 6. And that's going to give us positive 4. So the other place where we're going to intersect is at positive 4 comma negative 6. And we get those two answers right there. Okay, so let's see. I think that should be enough information to be able to practice this. So what I want you guys to go ahead and do is, let's have you do numbers 6 through 12 evens for the homework 2. On top of that, I do have a quiz that I just uploaded, so please make sure you complete that by Monday at the very latest, and hope you guys are doing well.